Hello, welcome back. Welcome back to the channel. I'm your sir here to guide you with the first chapter of mathematics. This will be, of course, I think the fourth video. Yes, this is the fourth video, isn't it? Fourth video. So in the first two videos we have, of the first video that was about the introduction of number systems. Second video we've done what is a set, different forms of sets. Third video we studied about different types of sets, empty sets, you still remember, right? Empty sets and so on. Today, in this video now, I am going to do a topic on called like operation of sets. Operations of sets. So basically we'll be having like four types of operations, okay, of sets, four types of operations. So it's going to be very simple, don't worry, I am there, no? Like don't worry, it's going to be a very simple topic based on four basic operations. So but like what I would require you, all of you dear students, dear friends, is like common sense, that presence of mind, that logic. It's more about the logic, mathematics. It's not I've been always saying memorization, completely no, absolutely no. It's more about like using your talents, using your ways to remember the formulas, using concepts, using local talents, I would say, using your own innovative ways to remember things. So, and for that, of course, common sense, very, very important, presence of mind. The first operation that we're going to be studying today is union of sets. Second operation will be intersection of sets. Okay. Third operation will be difference of sets. And the fourth operation will be complement of a set. So this will be the four operations that today we will be quickly in a very short video trying to wind up. Union, intersection, difference, complement of a set. So let's begin with union of sets. So for that, of course, I'll just explain you the concept, okay? Definitions and all, you have it in your textbooks, you can study from there and all, no? So I'm just going to study union. Okay, let's first again, I'll just try to tell you in few words. Union means that you will have some sets, combine them, that's called union, that's why it's called union, no? Intersection means like the common elements between two sets, okay? Union, combination. Intersection, common elements between two given sets, take that out. Okay, so that will be union, intersection. Difference would be subtraction, so it's like from one set, if it's A minus B, so from the set A you remove difference, remove the elements that are from set B. And complement, of course, that is only slightly different. Complement means all the elements which are not in the set A, something like that. So now for that, of course, I'm not going to explain the definition here. Just consider like two sets. Okay? So now union of sets will be denoted by A union B, A union B, U shape. That will be just combining the elements of the set. And as we know that elements are actually not allowed to be repeated, so we'll keep that in mind also. 1, 2, 3. Just combine all the elements in the given set. So that will be simply called union of sets. That is also represented is like A or B. That means the elements that you get, the set that you get after combining A union B, A and B, the elements will be either in A or in B, or in both sometimes. Okay, so that's why we use this word or, either in A or in B or in both. Okay, so that's simple. Bus, okay, union of sets, simple as that. Combine the sets. I think that's clear, right? Quickly then, what about intersection? So this one checked. Number 2, intersection. So I'll make it very quick. It's very simple. Intersection of sets. Now what is intersection of sets? As I say, it will be denoted by A intersection of set. That is like inverted U. So what did I say? Common element. So What do you see? Any common elements between A and B? Do you see? Yes, I see. Do you see? I see. Yes, see. So what is it? 3. So that's simple as that. A intersection B means simply common elements. That is also written as A and B. Okay, so that means that element that you get in the set A union A intersection B will be in A and also in B. So that's called intersection of sets. Of course, there's one condition that says like if A intersection B is like a null set. You remember there's no null set. Then this two sets A and B will simply be called as disjoint sets. Very simple. Disjoint means they have nothing in common. Okay, disjoint sets. Done. Then simple, isn't it? Very simple, right? Then third one, difference of sets. So intersection, check. So quickly, difference of sets, very quickly. Difference of sets, like subtraction concept, A minus B, B minus A. Simple concept. That means from the set, if it's A minus B, from the set A, if you have any elements which are present in the set B, remove them. Yes. So do you see from the set A any elements which are in the set B? I see 1, 3, isn't it? So from A, remove 3. That means I don't want anything that is related to B, like we will not talk forever, okay, like I don't like you, something like that, right? Same, B minus A. So in the set B, is there any elements that are from the set A? Again, 3, so 3 is like not like the B also, so B minus A will be 4 and 5. That is simply called difference of sets. Okay, done. A very simple concept, isn't it? Difference of sets, union of sets, intersection of sets, not a big issue at all. So difference of sets, check. Next would be complement of a set. Now complement of a set, for complement of a set, what we will need is we will need a universal set. And another set A. So basically the set A will be a subset of the universal set. So that means the universal set is like a bigger set, and we have another set, many sets we can have. So we'll just talk about one set here. Set one set from, that is like a smaller set of the universal set. Then A complement, so for that let me assume examples. 1, 2, 3, 4, 5, 6. Okay? And set A, I will assume 1, 2, 3. Okay? Now, how do we denote a complement of a set? It is generally denoted by A dash. Okay? Complement of a set is generally denoted by A dash. Or even sometimes U minus A. I hope you've got the idea now what you mean by complement of a set. U minus A. Huh? What did I say? A complement is generally the set. Sometimes we write A bar also. Okay, it depends, no? Sometimes we write A bar, we'll just use A dash. It simply means all the elements which are not in the set A compared to the universal set. So that means to get a complement of a set, you will have you need the universal set, or you need a bigger set. Then only we can compare with that particular set. Otherwise, it's not possible. Okay, so A complement will be all the elements which are not in the set A, opposite of A, reciprocal of A complement. So that's going to be like 1, 2, 3 gone. So that means 4, 5, 6. So these are all the elements which are not in A. Okay, that's simply meant by complement of a set. I give you another set B. 5, 6. So what will be B complement? 5, 6 already there in B. So what are elements which are not there in B? 1, 2, 3 and 4. Right? So that's a simple concept with complement of a set. Now based on that, there are some small incepts like applications that we get from complement of a set. Okay, from complement of a set. First one is, you can note down also. Okay, first one will be, okay, let me not forget the universal set. Maybe we will try to prove it also. 1, 2, 3, 4, 5, 6. My set A was 1, 2 and 3. Okay. The first one is complement of U universal set will be a null set. That's not true, isn't it? Because universal set, so all the elements which are not in the universal set is a universal set itself, so you cannot compare that because there is no another set. So null set. Similarly, complement of a null set is a universal set. That depends on the frame of reference. No, that depends on the particular question, because its universal set can change depending on the question. Okay, so not a big deal there. Third one is like complement of a complement will be A. Now what do you mean by this? Let's prove. What was A complement? 4, 5, 6. Fine. Let's get the complement of this complement again. Complement of this set. So A complement is 4, 5, 6. Now what is its complement again? So 4, 5, 6. It's again 1, 2, 3. That gives me again the set A. So that means a complement of a set of a complement, complement of a complement, complement of a set of a complement. Right. The complement of a set is the set itself. Okay. Alright. And another one would be A union A complement. So see, A, set A. A complement, all the elements which are not in A. You combine them, what will you get? Because A, 1, 2, 3. A complement 4, 5, 6. You combine them, 1, 2, 3, 4, 5, 6. What do you get? The universal set, right? And finally, the last one, A intersection A complement. So A intersection complement. So do you find anything in common? Here you are not going to find anything. So that's going to be what? A null set. Alright. So that's it for this video. Okay, it's a very short video based on because its concept is very simple. Don't take it like it's going to be difficult and all. No, it's very simple. So we have had discussed about how many concepts here? Like 4 concepts: union, combine; intersection, common; difference, remove, right? And complement, not present, present. No, just the reciprocals. Okay, so friends, I hope all of you are staying at home and then studying and preparing during this lockdown, and I believe that you are liking my channel, and then I hope that you have liked this video also. If you have liked this video, please hit the like button, and of course please do subscribe to get regular notifications, and please share it with your friends so that maximum of your friends can benefit from it. Thank you.